In the last class, I have asked you to fill out these entries, which means for class A, what is range of first byte? If the leftmost bit is 0, then it will range from 0 and then 7 zeros. These will be 7 zeros, 7 zeros to 0, and then this will be 7 ones, which means this will be 0 to this will be 127. So it will range from 0 to 127. This is for class A. Now similarly, class B is having 10 as a prefix. Then if 10 is fixed, then it will range from 6 zeros. There will be 6 zeros, 1 2 3 4 5 6 zeros to 10 and then 6 ones, 1 2 3 4 5 6, which means 0 0 0 0 0 0 and then 6 ones, 3 4 5 6 ones. So this number is 128 and this number is 191. So this is for class B. Now class B range will be 128 to 191. 128 to 191. Similarly, for class C, you have 110 as a prefix. So if 110 is fixed, 110 is fixed as a prefix, then it will range from 110 and then 5 zeros, because I am talking about the first byte only. Otherwise, IPv4 address is basically 32 bits, but I am only talking about the first byte. So it is 110 is fixed, so then you have 5 zeros, 3 4 5 zeros till 110 is fixed, then you have 5 ones, 1 2 3 4 5 ones. So this is 192 till this is 223. So you have 192 to 223. Now for class D, you have 11110 as a fixed number. So 1110, and then you will be having, these are the 4 digits, 4 bits, then you will be having 4 zeros, 1 2 3 4 zeros till 1110 is fixed, then 4 ones, 1 2 3 4 ones. This is 224 and this is 239. So you have 224 to 239. Similarly, here you have 240 to 255. That's how we can calculate the first byte in the decimal system for every class. And this is what I have written here. 240 to 255 is for class E. For class D, 224 to 239. That's how we can calculate these numbers for the decimal number system. Now let's talk about the classless addressing, which means here there is no notion of class. Here we need to explicitly define the prefix. See, in the class A, like in the classful addressing, for the class A, the prefix was 8 bits. Right? If you remember, prefix was 8 bits. Here prefix was 16 bits. Here prefix was 24 bits. Here, like in D&D, prefix, these things were not applicable. So 8 bits were the prefix for class A, 16 bits for the class B, 24 bits for the class C. Which means if I just say you that, okay, your IP address is 193. Let's suppose 3.3.7. This is your IP address. Then what is length of prefix? Then you will first identify that since this is the IP address, you will first identify that this IP address belongs to which class. Now by looking at just first byte in the decimal system, which is 193, can you tell me this IP address belongs to which class? This IP address belongs to class C. Why? Because in class C you have the range from 192 to 223. That's why this IP address is from class C. And then once you identify the class, then you can also tell the number of bits in the network ID, which means 24 bits you need for the network ID. 24 bits you have for the network ID in class C. That's how you can do it without specifying the network ID. So first step is to identify which class it is, and then next step is to identify what are the number of bits you require for the network ID in this class, right? But in classless addressing, there is no notion of classes, which means by looking at this 193. What was the IP address? 193.3.3.7. By looking at any of this IP address, you cannot tell me this belongs to some class, because there is no notion of class. Then what to do? Here, specifying or telling network ID is not implicit, which means we need to tell network ID explicitly. that network ID could be anything, maybe 16, need not to be 24, maybe 17, maybe 18, maybe anything. Okay, that network ID could be anything, and this network ID, like by looking at the IP address, you cannot tell me the network ID. You need to specify the network ID or the prefix length. Network ID is just a prefix, right? Network ID and prefix are same, so you need to tell the network ID explicitly. So here I'm saying 16, which means 16 is the width of network ID, or initial 16 bits are being used for the network, and later 16 bits are used for the host ID. This is host ID, this is network ID, right? And how we got to know this is the network ID? Because we have explicitly specified it. Okay, so we need to specify prefix explicitly, and generally we do it using the slash notation. So slash 16, slash 17, like that. So it like we had the example of 193.3.3.7 slash 16, which means this is an IP address, and this 16 is telling me that what is the number of bits in the network ID, what are the number of bits in the host ID. So this is network ID, this is host ID. Why? Because this is 16. I hope you got the idea. So for example, suppose this is an IP address, then this 8 is telling me that only first 8 bits are being used for the network ID. This 12 is telling us that first 12 bits, so basically these are the 8 bits, and then out of 14 you need to take only 4 bits. So 23 dot, so 14, like you need to represent that 14 into 8 bits, 1 2 3 4 5 6 7 8, and then there will be some representation of 67, I am not representing it. Then there will be some representation of 92, I am not doing it, and then slash 12. So basically initial 12 bits, so this is the 8 bits, and then these are the 4 bits. Initial 12 bits are used for the network ID. This 12 is telling me like that. Now what is 12 in binary? Let me quickly convert that and let me show you. 12 in binary, sorry, 14 in binary. So it is 1110. This is 1110, which means 0 1111, and then these bits are zeros, right? So this is our network ID, and this is basically telling me, this 12 is telling me that initial 12 bits are used for the network ID, and later 12 or later not 12, later 20 bits are used for the host ID. So this is one of the host basically. And what could be the other host possible? See, my IP address is 23.14.67.92 and prefix is 12, which means that I am using 12 bits for the network ID and remaining bits are being used for the host ID. So how many hosts are possible here? Just see here. See, 23.000. I mean, this is not very standard, which means like I'm just mixing up the decimal and the binary. I hope you got the idea. I'm not writing binary of 23 and binary of 67 and 92. I'm just writing binary of 14. Okay, so the zeros, then 1 1 1 1, then dot 67, then dot 92, and then 12, which means these bits are used for the network ID and rest bits are used for the host ID, which means this is one of the host. So if I ask you what could be the first address of the host, or the first address possible within this network, then you will say, see, this is the network ID, then first address possible within this network will be all zeros, 0 0 0 0 here, dot 60, like this could be anything, right? I mean, this will be zeros. Again, I'm writing in the decimal, so this is 0 and then this is 0. So this is the first address possible. So if I write everything in the decimal, it will be 23.0.0.0. This is the first address possible under this network. So basically this 67, 92 are irrelevant. Like it doesn't matter what you write, 67, 92, anything you can write, because anyway like you are going to change them, like these are, like these bits are changeable. You can change them from 0 0 0 0 to 1 1 1 1, right? So this is the first address possible. What is the last address possible? Which means this is fixed. See, this is fixed. These initial 12 bits are fixed. This is fixed. This is fixed. Then what will the last address that is possible? You need to take everything as 1 1 1 1 1 dot 1 1 1 1 1, everything is 1 here, and then dot 1 1 1 1 1. So basically this will be 23 dot, you need to convert this into that decimal, which will be 15 dot 255 dot 255. This is how you need to convert this into the decimal. So basically, see here what is happening. This IP address was given to you and I asked you what is the first address that is possible. So what you did, you just fix these things. Like these things are fixed every time. These things are fixed. And then for the first address, you can take everything as 0. Then this will be the first address. Now this is fixed. Okay, this is fixed. For the last address, you take everything as 1. And the decimal, it will be 255.255. This is last address that is possible for this network, right? I hope you got the idea. So let's take the next example, which is 220.8.24.255. 220.8.24.255 slash 25. So let's find out what is first address possible under this network, what is last address possible under this network. First address, last address. So for the first address, what you need to do, you need to put all the bits in the host ID to 0. So what are the fixed? So this 25 is telling me that initial 25 bits are fixed. So this is 8, 8, 8. So these are the 24 bits, and then this bit, like one of the bit from the 255, which is the first bit, is also fixed. So basically 220. So let me write here what are the fixed bits. 24 dot. Then this one is fixed. Then like apart from that, everything is like you can take everything from 0000 to 111. So basically for the 255 it is 11111 everywhere, but you can change that, right? So for the first address you will say 220.8.24. So it will be 1 is fixed. I'm writing in binary, then I will convert in the decimal, then everything is 0. So 7 zeros, 3 zeros, and then 4 zeros. This is how like you need to find out the first address. So if you convert everything into decimal, it will be 220.8.24. It is 2 power 7, which is 128. I hope you got the idea. This is the first address that is possible. What is the last address that is possible? This is 220.8.24.1. This much is fixed. Till now, it is everything was fixed. Then you need to take everything as 1. So 111, 11111, right? So this will be 220.8.24.255. This is the first address that is possible under this network. This is the last address that is possible under this network. So just notice one thing, like whenever you are writing /25, these last few bits, which are 7 bits in this case, because 25 bits are fixed, so last 7 bits doesn't matter. Either you write 220.8.24.255/25. This will represent the same network. See, either you write like this, or you write like this /25. This will also represent the same network. Why? Because here also these bits are same. These bits are same as this. Here also these bits are same as this. So basically you write either 220.8.24.255/25 or .128/25 or .255/25 or anything like apart from these fixed bits. You can change these bits to anything. Let me just change it. Let's say you are having some IP address which is 220.8.24. This one is fixed. Then let's suppose you are having some random number here which is 101101. Okay, let's suppose some random number. Let me count how many bits are there. 1 2 3 4 5 6 7, and let's suppose last bit is 0. So basically this is also representing the same network. So let me convert that into decimal. This is 220.8.24. It will be 110110110. 110. Let me convert like this. 110. What was that number? 110 11010 11010. If you convert, then it will be 218, right? So this is 218, and then you say /25. So basically either you say this, you say this, you say this, you say this, everything is same, because in all of this initial 25 bits are fixed, right? Initial 25 bits are fixed. Then you are changing these bits because these bits are anyway changeable. So you can change these bits. These all are representing the same network. I hope you got the idea. Because in all of this, either you say this, either you say this, you say this, you say this, you say this. In all of this, initial 25 bits are same, and that's what all matters. right? And because like last 7 bits are anyway changeable, so that's why all of these addresses are representing the same network, but the different IP address, obviously different IP address, but the network is same. So if someone asks you that what is the first address in this network, suppose someone says that what is the first address in 220.8.24.218.8.24.218/25, just find out what is the first address here. First address, what you will be doing, you will be converting this into like binary, and then you will say that initial 25 bits are fixed. So let's say initial 25 bits are this, and last the 218 you need to convert into binary, which is basically this 110 so basically it is a representation of 218. You will say that these bits are fixed, and then for the first address you will anyway convert this to 000s, right? So it will be 220.8.24.1 1000000. So it is nothing but 220.8.24.128. so this is the first address, which is same as this, right? Because these all of these representation are representing the same network. Now let's solve a question, which is this. It is saying given a classless address which is like this, find number of addresses in this, find the first address and find the last address. So 20, it is saying that 27 bits are fixed, which means this is 8 8 8, these are the 24 bits, and then from 82 3 bits are fixed. So 162.199.170 dot, let me convert this 82 to binary, decimal to binary, and then let me write 82 here. It is 1010010, 1010010. These are 1 2 3 4 5 6 7 and 8 bits. So they are saying that 27 bits are fixed, which means these are 24 bits and then these are 3 bits. So these bits are fixed. Now you can change basically other bits to find out the first address and to find out the last address. So first address will be, okay, first they are asking number of addresses. So how many number of addresses are possible? Since this is fixed, you can change these 5 bits, right? These are the 5 bits which are changeable. So you will say 2 power 5 addresses are possible. And what is the first address? First address will be 162.199.170.010 is fixed, and then you need to take everything else 0, right? This is the first address. You need to convert that into decimal, which is 162.199.170 dot, this is 2 power 6, which is 64. So this is your first address. Now what is last address? It will be 162.199.170 dot 0. The 010 is fixed, and then you can convert, you can change these 5 bits to 11111, right? And then you can convert this binary to decimal to find out the last address. This is how we will be converting, like we will be finding the first address, last address and number of addresses in a classless system. So this represents one network, and number of addresses in that network are 2 power 5 addresses. First address is this, last address is this. I hope you got the idea. So see here, the first address is this, which is this, and last address is this. So this represents the same network, this represents the same network, this represents the same network. So every of this represents the same network, right? Why? Because in every of these representation, these 27 bits are fixed. See here, these 27 bits are fixed. I'm just changing last 5 bits. That's why this number, this slash 27, this slash 27, this slash 27, every of this is representing the same network. See, I have given some prefix of n length, slash n means some prefix of n length. Then what I can do to find out the first address, I can put all zeros in the suffix, and to find out the last address, I can put all ones in the suffix, right? That's how we can calculate first address and last address. Now this first address is very special, and that is called network address. It is used for routing a packet to a destination network. So we will talk about routing in more detail in the future videos, but here I am only talking about the network address. Like how, why why first address is important, because this is a special address and that is called network address, and each network is identified by its own network address. So suppose a router is connected to different networks and some packet is coming from here, some packet is coming from here. Then based on the network address, like from this IP address, like there will be some IP address, some destination IP address from on this packet that is coming from this interface, right? And then router has to decide to which network it should route to this packet. Then based on the IP address, it will try to calculate the network address. So this unfortunately, basically this IP address does not contain any information about the network address or the prefix. Basically this IP address does not contain any information about the prefix length, which is \n. This IP address doesn't contain this information, but router has some way to calculate or to identify that in which interface I need to send this packet. That's what we will talk about in the future lectures. But for now I want to convey one point, is that each network has its own address, which is the first address. So suppose this network is 167.199.170.82, 167.199.170.82/27. This network is this. Then what will the address of this network? You need to take the first address of this. So I think it was 64. So 167.199.170.64/27, or you do not need to write the /27 because you are talking about the IP address. So basically this is your first address, or also called as network address. Now from this destination IP address, it will somehow try to capture the information about the network address. And if the network address happens to be this address, based corresponding to this destination IP address, then this packet will get routed to interface 1. So what is going to happen? A packet is going to come at this router. It will calculate the network address from the destination IP address, and if the destination IP address happens to be belongs to this network, then the packet get routed to this network. And how we will get to know that this destination IP address belongs to this network? Based on the network address. So we will find out network address from this destination IP address, and then we will route this packet to the corresponding network. That's why network address is important, and network address is basically the first address of the network. I hope you got the idea. Now there are two special addresses, like two more special addresses. One is directed broadcast address or direct broadcast address, which is basically the last address of the network. This is the last address of the network. So for this network, what will be the directed broadcast address? It will be the last address of this network. And what is the last address? Last address was, I think, 95. So sorry. So it is 167.199.170.95. This is directed broadcast address for this network. Now what is use of directed broadcast address? Basically, if some packet is having this as destination IP, okay, this as destination IP, then what we are going to do, like I will tell you how it is, how it happens, but for now I'm telling overall details. So some packet is, let's suppose, having this as destination IP. Then this packet, so suppose that that is having .95 as a the incoming packet is having .95 as a destination IP, then this packet will get delivered to every host in this network. That's why it is called broadcast address. Broadcast address means this will get transmitted to every host within the network. See here, the address is used by router to send a message to all hosts in a block or in the network. This is called direct broadcast address. Now there is something called limited broadcast address, which is basically always 255.255.255.255. Now this limited broadcast address is used within a network. address used to broadcast message only to host inside a network, which means if you are inside this network and you want to send packet to every of the host within this network, then you do not need to use this address, direct broadcast address. What you can do, you can just say 255.255.255.255, then this packet will get transmitted to every host in this network. So you can use this limited, or this is also called local. This is also called local broadcast address. Local means you can use it within the network only. If you are using outside the network, then this router will anyway discard this packet. This router is not going to transmit to every network. This router will anyway discard this packet. So this limited or local broadcast address can be used within the network only. Okay, if you are in the network and you want to send this packet to everyone else in the network, then you can use this address. Then this address will be sent to everyone else in the network. Now let's take this example, and here let's try to find out limited. Let's try to find out three things, which is basically direct broadcast address, or let me just call it DBA, direct broadcast address, limited broadcast address, and network address. Now limited broadcast address is always fixed, which is 255.255.255.255. And what is directed broadcast address? It is just a last address. And what is network address? It is just a first address. So you can calculate the last address and first address from this. To calculate the first address or last address, we need to check how many bits are fixed. So 23 bits are fixed, which means this is 8 bits, this is 16 bits, and then these are 24 bits, but these are not fixed basically. Sorry, these are 24 bits, but every of this bit is not fixed. Only 23 bits are fixed. So let me just represent this in the binary. So let's say this is decimal. Now I'm representing only the third octet in the binary. So this is the binary representation of third decimal number, right? Now they are saying that 23 bits are fixed. So they are saying that these bits are fixed basically. These bits are fixed. You cannot change them. Now try to find out the first address, which means you need to take everything else as 0. So what will the first address? 1.0. If you put this 0, then it will be 0.0, right? This is the first address, which is network address. What will the last address? You need to take everything else as 1. 223.1. If you take everything else as 1, so it will be just 1 only. Then it will be 1 dot. If you take 1 everywhere here, it will be 255. So this is last address or DBA. This is first address or network address, right?